Okay, so in this concept, we're going to talk about the factor theorem. Now, the factor theorem states that for a polynomial f of x, right, the binomial x minus a, some number a, is a factor of the polynomial f of x if and only if f of a, the number here, if you take it and plug into the function, you get 0, then this expression or this binomial is a factor of the polynomial f of x. Now let's see how this plays out in real time. So let's look at some examples. First example is to determine whether x minus 1 is a factor of this function, this polynomial function, x cubed plus 2x squared minus x minus 2. So let's apply the factor theorem. In this case, our a is equal to 1, okay? And this is our polynomial. Let's use synthetic substitution for this example. Okay, so a is 1, and then we can just write the coefficients to our polynomial. X cubed coefficient is 1, 2x squared coefficient is 2, minus x coefficient is negative 1, and then minus 2 is just the constant. Drop the 1, and then 1 times 1 is 1, 2 plus 1 is 3. Times 1 is 3, minus 1 plus 3 is 2. Times 1 is 2, minus 2 plus 2 is 0. Okay? So we know that the remainder here from the synthetic substitution process is essentially the same as calculating f of a, which is the value that's here, right? So f of a is equal to this number, this remainder. So since it is equal to 0, that means that x minus 1 is a factor of this polynomial. Okay? And of course, when we factor out x minus 1, we end up with, here we have the constants for the remaining polynomial. So we have x minus 1, and then we have 1x squared, and then 3 times x, right? And then 2 is the constant. Remember, degree, 1 degree, one lower degree in the polynomial, right? So this was an x cubed. The remainder here has a lower degree times the factor. Okay? And of course, we can factor this out further. We get x, and x, and then multiple factors of 2 that add up to 3 are 2 and 1 plus, right? So we end up with this times, of course, the original factor. So this polynomial factors to x minus 1, x plus 1 times x plus 2. Okay? Let's look at the next example. Determine whether x minus 1 is a factor of this function, x squared minus 2x plus 1. So this is another method, right? So we said that f of a has to equal 0. Well, we can use synthetic substitution, or we could just plug in a into the polynomial itself. Plug in a for x, right? Plug in the value of a for x, and then just evaluate. So in this case, a is equal to 1, so we just find f of 1. So f of 1 becomes, so 1 squared minus 2 times 1 plus 1. 1 squared is 1 minus 2 plus 1, which is equal to 0. So x minus 1 is a factor of this polynomial. Okay? Since f of 1 is equal to 0, x minus 1 is a factor. Next example. Determine whether x minus 3 is a factor of this polynomial. X cubed plus 2x squared minus x plus 2. Again, so all we need to do is find f of 3. So plug in 3 for the x's, right? So f of 3 is equal to 3 cubed plus 2 times 3 squared minus 3 plus 2. So 3 cubed is 27, plus 3 squared is 9, times 2 is 18, minus 3 plus 2. So minus 3 plus 2 is minus 1. 18 minus 1 is 17. And 27 plus 17 is 37. 40. No, minus 3 plus 2 is minus 1. 9 times 2 is 18, right? So 18 minus 1 is 17. 27 plus 17, 37, 44. Okay, this should be 44. Okay, since it is not equal to 0, then x minus 3 is not a factor. Okay, so we have some exercises here. Please pause the video, work on these, and come back for the solutions. Okay, determine whether x plus 3 is a factor of the following functions using synthetic substitution. So again, synthetic division and synthetic substitution are all about practice. It's something that you don't see too often unless you practice it. Okay, so the more you do of it, the more fresh in your mind it will be. So let's apply it here. So f of x equals x cubed plus x squared minus 2x. So my a is negative 3, remember, because I need the form x minus a, so I need x minus negative 3. So my a is negative 3. So I have negative 3, and then I have all the coefficients of my polynomial. So 1, 1, and minus 2, and then this is the same as plus 0, so here is 0, right? And then we do this to get the remainder. So drop the first term, 1, and then 1 times minus 3 is minus 3. 1 minus 3 is minus 2. Minus 2 times minus 3 is 6. Minus 2 plus 6 is 4. 4 times minus 3 is minus 12. 0 minus 12 is minus 12. So since the remainder is not 0, that means x plus 3 is not a factor of this polynomial. Okay? Let's look at the next exercise. Minus 3, and then we have 1, 3, minus 10, and 0. Okay, do this to get the remainder. Drop the first term, 1, and then 1 times minus 3 is minus 3. 3 minus 3 is 0. Remove the arrows. 0 times minus 3 is 0. Minus 10 plus 0 is minus 10. Minus 10 times minus 3 is 30. Let me just write it off. Yeah, 30, right? 0 plus 30 is 30. So again, my remainder is 30, which is not equal to 0. That means x plus 3 in this case is not a factor, okay, of this polynomial. Next exercise, show that x plus 5 is a factor of the function f of x equals x cubed plus 6x squared plus 3x minus 10. Let's try the other approach, right, of just plugging in. So here my a is equal to minus 5. So all I need to do is just find f of negative 5. So x cubed, so minus 5 cubed is minus 125 plus, so 6x squared minus 5 times minus 5 is 25 times 6, which is 150 plus, so 3 times minus 5 is minus 15 minus 10. Okay, so minus 125 plus 150 is 25, minus 15 is 10, minus 10 is 0. Okay, so x plus 5 is a factor of this polynomial. Okay, this is it for this concept. See you in the next video.